Hey, good morning, guys. We've got some inequalities in two triangles to discuss today, in particular the Hinge theorem. Very exciting. Hey, if we're going to do hinges, do we need tools? Ha! Probably not. All right, so what's worse, bad dad jokes or bad math jokes? I don't know. All right, so but before we get started on the Hinge theorem, we're going to talk about the review of 5-5. We're talking about how to determine what sides are larger and what angles are larger. So we're going to write the angles in order from smallest to largest. So the first thing I notice is we have 7, 8, and then 9. And so I know the angle that is opposite the side length that is 7 is going to be the smallest. So I know that the measurement of angle C is going to be less than the measurement of angle B, because that's across from the 8, which is going to be less than the measure of angle A. Write the sides in order of smallest to greatest. All right, same basic idea. And we have a missing side length right here, or angle. And so I do 61 plus 59, and I get a number that is definitely, well, so when I add those together, I get 120, right? So 180 minus 120, and this is 60. All right, so that means the smallest side is going to be opposite the 59-degree angle. So that means side length DE is less than side length EF, because that's across from the medium angle, which is less than DF. The length of two sides of a triangle are 17 and 12. Find the range of the third side. So the first thing that we can assume is, well, let's assume that 17 is the longest side. Well, if 17 is the longest side and the other side length is the smallest side, I know that 12 plus that other angle, let's put a question mark, has to be greater than 17, which means that question mark has to be greater than, what is that? That is 5. So we know that at a very minimum, our side length has to be greater than 5. Well, let's assume for a second that it is the largest side. That question mark is the largest side. That makes great video, doesn't it? All right, so we're going to assume that x is going to have to be less than 17 plus 12. So that means x is less than 29. So we know that the range of side lengths is going to be between 5 and 29. And it cannot equal either. Tell whether a triangle can have sides of this. All right, so if I do 2.7 plus 3.5, for this to be a triangle, it has to be bigger than 9.8. So when I add those together, clearly this is not bigger than 9.8. I get something like 6.2. So therefore it cannot be a triangle. All right. Fun stuff. All right, so Hinge theorem, here we go. So the Hinge theorem says, all right, so let's say I have two triangles. So let's say I have this triangle here, and then let's say I have this triangle here. And as luck would have it, this side is congruent to this side. This side is congruent to this side. So I'm going to label these. Let's say we have A, B, C, X, Y, and Z. All right, so here's the thing. If we have two congruent side lengths, and I know that angle A is greater than angle X, then my conclusion is going to be that BC, oh my gosh, well, it doesn't look that way, but oh well. So BC has to be greater than YZ. Now I realize my drawing is not to scale, please forgive me. So again, I'll write it a little bit smaller. BC is greater than YZ. Because if these two sides are the same, these two sides are the same, if this angle ends up being bigger than this angle, then clearly the opposite side also has to be bigger. All right, so our next theorem is the converse. And so the converse is simply going to say we're going to say that A, B, and C and let's go with this one. So we have that's the ugliest triangle ever. And we are going to say that these are congruent. We're going to say that these are congruent. And we are going to say, we're going to make the statement that we're going to make the statement that BC is greater than YZ. Well, if that's true, then we can conclude that angle A must be greater than angle X. And so that's the converse of the Hinge theorem. So that's what we're going to be dealing with today. Best day ever!